Hi, let's talk about trigonometry ratio today. This is only used when you have a right-angle triangle. Let's choose this as your angle. Then the opposite of the angle is the opposite. This is the adjacent, and this, the longest side, okay, is the hypotenuse. The thing is that, the trigonometry ratio is just simple, relation between the angle and the legs and the hypotenuse, right? Many of you actually think that this is somewhat complicated, but it's just like a simple rule that you just have to remember, like 1 + 1 is 2. So there are 6 different ratios: sine, cosine, tangent, cosecant, secant, and cotangent. Sine of the angle has to equal to opposite, right, over hypotenuse. And cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And the remaining 3 is actually the reciprocal of the previous one. Cosecant is 1 over sine. This secant is 1 over cosine. Cotangent is 1 over tangent. So just remember the ratio and the angle and what sine, cosine, tangent has as its ratio. That's all you have to do. Okay? And the reason why we are doing it is because, like, imagine that you have a right angle triangle given. Say you know what this hypotenuse is. However, you have no idea what your legs are. Now, if you have another length, then you can easily use Pythagorean theorem to look for the missing value, right? However, since both of them are missing, we have to have another information. Well, this is 40 degrees. If you know the angle of one of the vertex, then we have enough information to look for the 2 remaining values. So we have the hypotenuse, right? This is the opposite of the angle, right? This is the adjacent of the angle. So if you want to look for the x, the opposite of the angle, now you have to think, ooh, I know the hypotenuse. I want to look for the opposite. Is there a ratio that, tells me something about the opposite and the hypotenuse? Well, there is. This one. You see how sine of 40 degrees should equal opposite over hypotenuse? So technically, that should equal x over 5. So if you plug in 5 times sine 40 degrees in your calculator, that is the length of x. And for the same reason, since y is the adjacent of the triangle, if you use the cosine, where you can use the ratio for the adjacent, y over 5 hypotenuse, right? You may get your y as 5 times cosine of 40 degrees. So put that in your calculator and you will be getting your x and y. Really simple. Learn the ratio and you'll be okay. So basically, do you remember the special ratio, the 2 special triangles with a special ratio given to it? If you apply this, you can actually evaluate quite many special or ratios. So we can actually understand what sine of the angle, cosine of the angle, and tangent of the angle for, well, 30, 45, and 60. They're special, right? Why? Because the 30-60 has a ratio, right, of, do you remember? Of if the longer leg is √3x and shorter x, right? Then the hypotenuse is 2x. So technically it is 1 to √3 to 2, right? And what about 45? 45 is an isosceles right angle triangle. And this one, since this is 45 and 45, if this equals to x, then that equals to x. And this then is square root of 2x. Hence, the ratio is 1 to 1 to square root of 2. When you actually use the ratio as the length, right, you actually can get what the sine of 30, cosine of 30, tangent of 30 is as an exact value. Sine of 30 is 1 over 2. Why? Because it's opposite over hypotenuse. Cosine of 30 then will be adjacent, right? 30 is right here, guys. The adjacent is this. So root 3 over 2. And tangent, right? Tangent of 30 is opposite over adjacent. So you may write this, or you can rationalize it by multiplying both by root 3. Hence, get this. For 45, it's 1 over root 2, 1 over root 2 for both cosine and sine, because the adjacent and the opposite are both 1. So 1 over root 2, or 1 over square root of 2, or again, root 2 over 2, square root over 2. Okay? So technically, you're expected to memorize all this, but if you don't have such a good memory, just understand how we have come up with the values. It's actually given from the triangle, so you don't have to panic about having to memorize it. Okay, so 1 over 1, because the opposite and the adjacent is both 1. And for 60, well, 60 we have to use the first triangle again. And the opposite now is root 3. So square root of 3 over 2 of adjacent of this is 1. So 1 over 2. And finally, the tangent of that is opposite over adjacent, which is square root of 3. So those are the values that you need to remember, because these are the exact values. And they come from the special ratio triangle, so you don't have to just memorize it. You may calculate for them whenever you have to. All right, so there are other angles that you should understand as well. Well, actually, 90 and 180. Well, those are, it's good to remember, what the values are at 90 degrees and 180 degrees as well. Well, sine equals to 1 for 90 degrees, cosine equals to 0, and for tangent, there's no value. Okay? Sine equals to 0, cosine equals to -1, and tangent equals to 0. It's handy when you graph them, because you're supposed to at least mark the important part of the values, the points, right? And the zeros are always important. So know when your zeros appear. Okay, so these are the simple ratio, and those are the special values that you have to remember. Okay, now let's just talk about some other problem where the ratio is simply used. If we are solving for a missing value like we were doing before, all you have to do is just put the numbers into the ratio and then just use your calculator to get the outcome. However, what you're gonna do if this is what you have, you get some random right angle triangle, and you get the angle as x, and you know what the hypotenuse is in terms of, say, A. Then the question then asks, what is the area in terms of x and A? What we're gonna do when such questions come up, we have no idea, because we don't know anything about it. The angle is given as x and the hypotenuse is given as, well, A. So what are we supposed to do to get the area? Well, the hint is that they actually told us to look for the area using x and A as they are. So what you have to do is just consider this. What do you usually do when you're looking for the area of a right angle triangle? Don't you look for the length of the two legs and multiply them and divide it by 2, right? You look for the base, and you look for the height, and you multiply and times it by 1/2, right? So let's just try looking for your base and the height, but this time using A and X. So again, remember what we did in the very beginning, the triangle with 40 degrees and 5? I said, since this is the adjacent, you see, the angle is right here. So this B is the adjacent. Height is across from it, so this is the opposite. And this A is the hypotenuse. So if you're looking for B using A and X, you have to think about, oh, how can I get the adjacent knowing the hypotenuse? So we are looking for a relationship between adjacent and hypotenuse, and it's right there. Cosine of the angle x should equal adjacent b over hypotenuse a, right? So b, right, equals to base, right, a times cosine of the x. I just got my base b in terms of a and x, right? What about the height? That's opposite, so we are using the very first ratio. Sine of the angle is supposed to be the opposite over hypotenuse, right? So your height should equal a times sine of the x. Hey, we got the base and the height in terms of a and x. Now, so for the final step, hence the area is base a cosine x times height a sine x over 2, which equals to a squared sine x cosine x over 2, and that is the answer. I mean, it's not that pretty. I mean, it's not an well, appealing answer, but it is the answer, and it's correct. And we just simply use the ratio in order to come up with a conclusion, right? Simple ratio is all you need. Isn't this fun? Okay, so there are some questions with right angle triangles. They might ask you to look for the length or the missing measurement, but sometimes they do ask you about something without giving you any of the measurements, right? When that happens, well, you still have to use the same ratio. Right angle triangles means using the ratio. And all you have to do is just remember this beautiful ratio and remember that these are just reciprocal of each, you know, sine, cosine, and tangent. Okay? Well, cosecant, secant, and cotangent are not usually used directly when, you know, when having to look for the missing value of a right angle triangle. They are, you know, discussed for the function part and also for the identities that we are going to discuss today as well. Okay, so let's move on to the more trigonometry. Well, first of all, I have wrote down 30, 45, 60, and 90, and 180 degrees just now, right? It's just that degrees are the angle measurement that people are more familiar with. But however, starting from pre-calculus and especially in, well, calculus and further on, radians is used, well, more often. It's just another angle measurement. It's just that it uses different scale. Well, to be exact, pi radians, right? So 3.1 something, right? Equals to exactly 180 degrees. So when you see a straight line, when you are measuring this using, you know, degree unit, you will be measuring 180, right, little degrees, right? However, the same angle measurement is measured as pi radians. So 1 radians is rather big, you know, compared to 1 degree, right? So this, you know, doesn't mean that the radians is always given in terms of pi. Like I just said, 1 radians is totally fine. It's just that pi radians happen to be exactly equal to 180. So we actually use that as the set ratio to convert radians into degree and vice versa as well. Okay, so let's just do a quick example on that. You make, you know, I used to come up with a formula, but actually radians over degrees, the ratio is actually simple enough. The set ratio for radians to degree is pi over 180 degrees, right? So whenever you're converting degrees to radians or, well, the other way around, all you have to do is just put the values that you're given, well, into the ratio and put x for the missing value, right? And just solve it. So if you're to convert, we had 45 degrees just now into radians, right? All you have to do is do x missing, right, over 45 degrees given equals to pi over 180. and find the value of x by, what do we have to do? 45 times pi over 180 degrees, which equals to quarter of a pi. Hence, the 45 degrees equals to pi over 4 radians. Exactly. And for at least for 30, 45, and 60, 90, and 180, right? Always, like, you should be able to tell what this is equal to in radians right away. It really helps when it comes to solving for questions, or like when you're looking at the function, because many of the functions are actually using the, radians, measurement for the scale for the x, for the angle part. So anyway, so 30 degrees, if you apply the same ratio, but simply put 30 here now, you'll be getting 1/6 of a pi. This was a quarter of a pi. This is a third of a pi. This is, well, obviously half of a pi, right? And this is just pi. So just, get used to this. These are 30, 45, 60, and 90 degrees. So that's how you convert it. Don't forget the ratio, guys. It's pi to 180. Okay, pi radians to 180 degrees. Okay, so now we know that there are actually two different measurements when it comes to angles. Now, angles are actually graphed on a plane, quadrant plane as well, because if you think about it, once you start from a point and if you go 360 degrees around, right, you're back to where you were before. So technically, position-wise, right, on a plane, 360 degrees might as well be 0 degrees. Or it can be equal to 720 degrees because it's keep coming back after 360, right? This point can have so many angles, right, as its measurement. So technically, that's why we get something called coterminal angles. If you add your angle, if it's given in degrees, right? If you add any numbers of 360s, okay, to the given angle, it still is in the same position. Hence, they are all coterminal. If it's in radians, then you will be adding it by 2 pi because that's what 360 is. So coterminal angles basically mean that the angles that do lie on the same position as the given angle. Really simple. Add the angle by 360s, any multiples of 360s, or 2 pi's, depending on what unit your given angle is. Okay? All right, so that's first thing that you have to understand what the coterminal angle is. Okay, but more importantly, we need to understand something else. We need to understand a reference angle. And before we talk about reference angles, I need you to remember something. I'm pretty sure most of you have already seen this. All, so sine, cosine, and tangent, all, and then sine, right? Tangent, C. So, everybody makes up different phrase for this, sentence for this. All students towards college, or all students, towards calculus. Anyways, so what is the meaning of this? It means that, how we said that if you go 360 degrees around on a plane, then it's back to square one, right? Well, the thing is, when you are measuring angle from a plane, there are certain rules that you have to follow. Well, first of all, the positive x-axis, right, is always the initial, this is the initial state where you start measuring your angle. So whether you're measuring 100 degrees or 10 degrees or 270 degrees, right, you always have to start from this, part of the axis. And there's another thing. You must measure this in the counterclockwise direction if you want to measure the angle positive. But doesn't mean that you can't, measure it the other way around. It's just that if you do, you're basically getting the negative angle. Okay? So again, if you want to go 100 degrees and find out where that point is going to lie in, all you have to do is just go 100 degrees from here and stop. And so your point will be somewhere here. If you want to go negative 30 degrees, then you will be going the other way around for 30 degrees. So that's negative 30 degrees. Okay? So if you're doing it in terms of pi, well, if you want to go 3/2 of a pi, well, remember how 90 is half of a pi? So 1/2, 2/2, 3/2. That will be 3/2 of a pi. Okay, is that clear enough? So we start from here, this way positive and this way negative. Okay, so the thing is, so we do measure the angle from here. And when you apply the angles into sine, cosine, or tangent, right? Depending on what your angle is, or in which quadrant your angle is in, the sine of the angle, or the cosine of the angle, or the tangent of the angle, sometimes will have a negative value, or sometimes it will have a positive value. And this is, showing when and what is staying positive, actually. If your angle lies between 0 to half pi, which is, well, actually we call this as quadrant 1. So if your angle lies in quadrant 1, all sine, cosine, tangent of that angle is going to be positive. If your angle lies from half pi to pi, so from 90 to 180, then the only ratio that stays positive is sine. So say if you are plugging in 100 degrees into sine, it will stay positive, but cosine of 100 degrees or tangent of 100 degrees will give you a negative ratio. So here, anything between 180 to 270 will keep tangent positive, but rest negative. And finally, anything from 270 degrees to 360 degrees will keep cosine positive, but sine and tangent negative. So that's what OSTC means, the ratio that will stay positive for each quadrant, right? And remember, this is, the first part is quadrant 1, then it goes this way, counterclockwise, direction, guys. 1, 2. This is the third one, and this, the fourth one. This is a very, very important concept, guys. Do not ever forget. Don't forget the order, and don't forget what stays positive for each quadrant. Okay, now that we have understood the meaning of quadrant and what stays positive and what becomes negative, now we can actually talk about reference angles. Reference angles are basically equal distance away from the x-axis, like above or below, doesn't matter. So technically, so on a quadrant plane, say this measures something, right? We'll say 40 degrees, okay? Then you will have bunch of, well, actually, exactly 3 other, right? That will be equally away from the x-axis, above or below. Technically, then if you measure each of the angle properly, right? Remember how we have to measure them from here, going this way? Well, the first one is 40, but then the second one is actually 90 plus 50. It's actually 40 short from being 180. So the second angle is 140 degrees. What about the third one? It's actually 40 more than 180, so that equals to 220 degrees. And finally, it's 40 less than being 360. So, so it's 320 degrees. These, guys, are reference angles. Okay? It's just basically same distance away from the x-axis. However, depending on which of the 3 trigonometry that you are using, you have to choose only two in pairs as a pair as the reference angles. Like for example, if you are given sine of 40 degrees, right? And if you're looking for a reference angle, it means that you're looking for another angle that will give out the exact same ratio. Okay, here we go. I just said it. Reference angles are special because the sine of the angle or cosine or the tangent of the angle and the reference angle of that are equal in terms of ratio. That's why they're so special. And since even though 40 has 3 other reference angles, right? There's only one that will stay, well, positive. Because sine 40 is positive, isn't it? Everything was positive here. When, was sine positive here or here or here? Remember when sine was positive? Sine was positive in the second quadrant. So technically, we know that sine 40 equals to sine 140 degrees. Okay? That's, why we have to understand reference angle so that we can actually see what other angle value is equivalent to the one, given from the other quadrant. So if I'm doing tangent, right, of 40 degrees, then I know that tangent is also positive here as well as there. So I know that it's 220 degrees that I have to use. Okay, so then what will happen if I choose tangent of, say, 140 degrees by accident? So are they like completely different? Well, actually, the values are the same, but the signs are different, actually. Where you know how these are both positive? Remember I said like how if a sign is written here, it means that the sign is positive and the rest is negative. So basically, the ratio is the same, but for this, you will be getting a negative of the ratio. Okay? So we can still figure out what tangent of 140 degrees is. It's just that the sign has to change, so they are not exactly equal to each other. But we may use this in order to find what this is. And also, hence sine of 320, since it is also the same value but negative, these two are equal to each other. So that's what I meant by they come in pairs. Okay? So because 2 of them will give you positive ratio, the other 2 will give you negative ratio, and depending on whether it's sine or cosine or tangent, you need to know which 2 are in pairs. Okay? If for cosine, the 40 has to be paired up with 320, both positive, right? And 140 and 220 will become negative. So just like that. That's what you need to remember. And hence, okay, so remember this, how we said sine of 30 degrees is equal to 1/2. Okay, so this is why we were talking about reference angles. If your angle lies between 0 to 360 degrees, we can actually find out another angle value that also equals to 1/2. What is that? Remember, reference angles will give out the same ratio. Since it's 30 degrees, everything else has to be 30 degrees away from the x-axis, right? And since this is positive, we have to look for the reference angle from the second quadrant. What is the angle measurement of that? 150 degrees, okay? So the another angle value that also equals to 1/2 will be 150 degrees. That will equal to 1/2. What about sine of 30 more than 180? So 210. Or sine of 330. What about this? They both equal to negative 1/2. They still have the same value, but the signs change. Okay? So that is how you use your reference angles to understand that there are more than one angle value that has the same ratio in the interval between 0 to 360. Excuse me. And also that if you know the positive ratio, we can also find out which two have the negative of the same ratio. So we can actually, this actually says something. It actually says that the bunch of angles will have the same ratio throughout the function. Actually, we'll be talking about functions in the next lecture, and when I give you the graphs of sine functions, you will actually see things a little bit more clearly, how the ratio behaves for each angle throughout the entire domain. So at least for now, remember this. Can I just talk about quadrant plane a bit more? Sometimes you're supposed to look for the angle, knowing the position of a point. Say you're given, let's go easy, -1, 1. So you have to plot the point, so -1, 1. So it's right here, isn't it? If you're to look for the angle of this point, all you have to do is, you just need to measure the angle from here. Hence, what you should do is create a right angle triangle, because you know what the coordinate points is for the x and for the y. We can actually use them as the length of the two legs. And, well, for this, it's actually quite easy. We don't actually need to use the calculator since they're both 1 distance-wise. It's obviously isosceles, hence 45 and 45. And since we are supposed to measure the angle from here, 45 isn't the answer, but 135 degrees is. Okay? So that's how you can, or if you have to convert that into radians, 3/4 of a pi. That's how we, sometimes measure the angle. You have to measure it from a given point given, from a question. So don't panic when you have to do this. Just sketch it out, create a right angle triangle, and, work on it. Okay, one more question regarding, well, angles or ratio. Okay, here we go. Now, what if you're supposed to do something like, let's see. Ooh. What if you have a right angle triangle and you don't know what the point is, but all you do know what the angle is, the ratio is. Like, for example, it's actually the same question as this, but this time I'm not going to give you 30 degrees. What if you have to find all angle values between 0 to 360, where the sine of the angle is equal to, say, 1 over square root of 3 over 3. What if you have to do this? Well, for some people, you might remember this ratio from the previous page, right? However, for those who who has no idea what root 3 over 3 is, how are we going to get the angle? Well, here I've given you one of the angle, hence we use the reference angle rule to get the other one, right? Because that was rather easy. What if you don't know any one of them, and if you don't remember the ratio? Well, you have to use the calculator, of course, right? And well, technically, we are trying to figure out this. So somehow we have to take this out. How do we do that? Well, very simple, using inverse. Really, really simple, guys. You just put inverse and you may swap these around. So, if you look at your calculator, for any calculator has sine x, right? And on top of that, it has inverse of sine. So all you have to do is just get that button and then type in square root of 3 over 3 inside of the parenthesis and enter on it, and your angle will then be equal to 60 degrees, right? Or pi over 3. So since I told you to find all between 0 to 360, once you have found 60 degrees, you might wonder, oh, so is there another angle? How do I look for it? So you might probably type this in again and again. And the thing is, no matter how many times you type this in, you will always get 60 degrees. The thing is, the calculator always tells you the closest value to 0, right? So they don't tell you the remaining angles, because technically, there are infinite many. Remember what I said about coterminal, right? It's just that, by the way, coterminal also has the same ratio. So if you plug in 0, 360, 720, right? They will, into sine, cosine, or tangent, they will all have the same ratio. So they can only tell you one of them by just showing you the closest one to 0. So you have to actually use this concept in order to get the remaining angle values, if there are any. And for sine, since the ratio was positive, again, using the same rule, sine is positive here and here. And since it was 60 degrees, right, there should be another one from 60 degrees from here, right? Hence, that is, what is that? 120 degrees. 60 less than 180. 60 or 120. You can get this from your calculator, but you have to do this by hand. And don't forget the inverse sign, guys. The inverse is just telling you what the angle is when you know the ratio. Let me just re-emphasize on that. So if you have sine, say, of A equals to B, this is the angle part, and this is the ratio part, right? Well, to be exact, it's the opposite over hypotenuse. But if you see inverse A equals to B, that is the ratio, and that is the angle. Simple, right? As well as this arc. Sometimes they can use arc in order to mean inverse. Okay? So when you see arc, don't panic. It just replaces the inverse part of the ratio. Okay, so reference angles, like I was keep saying, is important. And we just, I just showed you why. Calculator can't really help you there, right? So remember how to get the reference angle, and please do remember what stays positive for each quadrant. Okay, now let's move on to something really fun. Identities. Identities are actually really fun because it's actually showing you a relationship between the bunch of ratios. So, sine and cosine, like technically, like, okay, so it is fun, I think. Okay, say we have some random right angle triangle. I'll call this as, right, Pythagorean works, right? So technically, if this is your angle, well, sine of the angle is, what, 4 over 5, right? Cosine of the angle is 3 over 5, right? So if you square them, sine squared, you get 16 over 25. Cosine squared, you get 9 over 25. What do you get when you add them up? When you add them up, you get 1. Excuse me. The identities basically tells you something that is just a fact, right? However, we don't have to prove them. I mean, you could, but then the thing is, if you just memorize the facts, right, it can be really helpful when you're doing your further math for the test and for calculus and, and more. So please do understand what these identities are. It's just a simple facts between the ratio. So if you do add 1 by square of tangent, it does equal to secant ratio squared, okay? So once you memorize them, you may use them into, in order to find and look for some other stuff. Like, for example, for sine, you already know what sine of 30 degrees is, right? We've been using it for the previous page. That equals to 1/2, right? Now, imagine having 30. Oh, let's apply this with this identity. It says sine twice the value is equal to 2 times sine of the angle and cosine of the angle, which means technically if you have sine 2 times 30, which is 60, right, should equal sine of 30 and cosine of 30 degrees. Now that equals to 60 degrees, right? And sine 30 equals to 1/2. Do you remember what cosine of 30 was? Cosine of 30 degrees was equal to root 3 over 3, 1 over root 3, remember? 1 over root 3 or square root of 3 over 3. So technically, what you will be getting is root 3 over 3. And if you go back to your table, that's exactly what sine of 60 was. I'm just like using the easy numbers so that you can prove it. You see? It's just a fact. Okay? And the thing is, well, 30, 60 were the values that we already knew, but for instance, if you plug in 30 in here, you know, you see how you get 15 degrees? Do we know 15 degrees? No, we don't, right? So if you put your values into this identity, hence you put 1 minus cosine of 30, which is root 3 over 3 over 2, that is, you know, your ratio for sine of 15. It actually helps us find the exact value of some angles that we don't know, okay, by the special ratio. But for, well, there are a bunch more identities. There's a sum identity, difference. I mean, there are many more, but I'm only trying to emphasize on the identities that are very crucial, like the things that you have to actually really remember for your math subject test. Well, honestly, for questions like this, no one uses the identity for this exam because it's, you know, you can just plug that into your calculator and get it right away. But it's just that there are times when a calculator is not going to help you with a problem because it's not given by a measurement. Remember the area question that we did before? We used the ratio to get what the base and the height is in terms of a and x, right? It was kind of ugly, but it was doable. Same question, or similar questions are asked. Instead of telling you like that this equals to something, a number, right? They tell you that something equals to, like, say, t, right? So for those, if you do know the identity, it can really help you get the problem done faster. And well, sometimes you cannot do it without knowing the identity. So again, if it's given as a measurement, like say like a number, right? Then you'd better use the calculator to get it. But if we ever see questions where calculator is not going to help us, then you have to use the identity. So for this question, guys, if you don't know what half angle identity is, then there's nothing else you can do. Well, actually, there's something that you can do, but it will take a little bit longer. You may like plug in a number and, you know, to guess and check, kind of. But anyways, this is much easier. If you do know the identity, then you know that this should equal 1 minus cosine of the angle over 2. And since cosine angle is t, the answer is 1 minus t over 2. Well, it's just that, oh, here, guys, could you please add plus or minus here? Well, it's just that depending on where the angle is, it could come out as positive ratio or negative, right? So it's technically positive or negative square root of 1 minus t over 2. That is the answer. And you see how easy this is if only knew, if you only knew the identity for half angle sine. All right, now for second example, again, the identity is what you need, but this one is for the double angle identity for sine. So what is the identity for twice the value of angle? Right there, right? 2 times sine times cosine of the angle. So, okay. Oh, we're still stuck though, right? The previous question, all you had to do was just plug in the t, but here, we know this, but how are we going to get that? Well, for this, we may set up a triangle. Well, actually, I do love doing that, but since we are talking about identities, since you're looking for cosine, and since you know what sine is, that's m, right? Look for the identity that tells you the relationship between sine and cosine, the very first one. Sine squared, hence, well, m squared, is supposed to equal to, right? So technically, cosine squared of x should equal 1 minus m squared. So cosine x should equal plus or minus square root of 1 minus m squared. So, well, as long as so it's just like saying that if angle was in the first quadrant, right? Then you may put positive root 1 minus m squared as cosine. If your angle was in the, third quadrant, right? Then it should be negative. So you can put plus or minus as square root of 1 minus m squared as cosine x. And this is what sine 2x is in terms of m. And that's how you can use identities in order to look for some weird looking problems. You have to know the identities. So please study them. Come back with functions the next time.